This is a video to explain how to calculate absolute zero. We calculated absolute zero in class today, and I got a value of about 7 degrees Kelvin away from the accepted value, which is 0 Kelvin, is absolute zero, which is the minimum energy that a particle can have. In the experiment we did today, we have a thin tube which has the same diameter all the way up and down the tube. There's a section of air followed by a section of sulfuric acid or mercury, followed by another section of air. This air section has a small hole in the top to allow this air to contract or expand like it would with changing temperature. So this air can get pushed in or out, so the pressure doesn't affect this being able to contract and expand. The reason this section can be air or sulfuric acid is it should be sulfuric acid, because sulfuric acid will remove the water from this air and make it, sulfuric acid will remove the water from this air and make it dry air, so we don't have any water molecules that are in the air affecting the experiment's result. What we do in the experiment is submerge this air section. It doesn't matter if you submerge it all, but you need to submerge at least up to here in water at 90 degrees and measure with a ruler the distance from the bottom to the mercury, so you know how much air is in there, and then submerge it in water at 80 degrees and the air will have contracted, so this level of sulfuric acid or mercury will have moved down, and then measure the distance from the bottom to this level again, and carry on doing that at set intervals. We'll use 10 degrees, so 70 degrees it would have moved down another bit, and by the time we get to 0 degrees the air is going to have contracted all the way down to here. The displacement of this acid or mercury was recorded every 10 degree change in temperature. These were the results I got in the experiment today. We should know that when a gas gets colder, it occupies less volume. You can see from my results that as the temperature goes down, the volume of air in the tube goes down. This is temperature in Kelvin. 1 degree change in Kelvin is equivalent to 1 degree change in Celsius, so these are going down. These are changing in multiples of 10. 363 degrees Kelvin is 90 degrees Celsius, and they're going down in 10, so 90. This is 80 degrees 76. After we obtain these results in a table, we put them in a graph like this. The graph has temperature from 0 to 400 degrees Kelvin against the length of air in the tube from 0 to 13 centimeters. Because it's going to be difficult for me to draw these points on here accurately, I've got a picture of my graph that I drew in class today. So what I'm about to do on here should look something like this. So the points on that graph looked roughly like this. There's 9 points, one for every 10 degree change in temperature. After we draw those points, we draw a line of best fit through points and carry on until it hits the x or the y axis. And if we've done the experiment perfectly, we've got good values here. It should go right into the corner, and where the volume of the gas disappears, that's when the temperature is absolute zero. I've not drawn this line right into the corner because in my experiment I got about 7 degrees less than absolute zero for my value. In the experiment we used the fact that the volume of air changes as the temperature changes. This is how a thermometer works. The liquid in a thermometer expands or contracts like a gas as temperature increases or decreases. So why couldn't we have just used the thermometer for this experiment? Well, we could, but if you heat a gas by 10 degrees and you heat a liquid by 10 degrees, the amount the gas expands is greater than the amount that the liquid expands. So gas is better to use for this experiment because in a gas a smaller change makes a bigger difference, and a bigger difference is easier to distinguish between. It's like if I wanted to find the mass of something with a really low mass, like this tiny little ball. If I wanted to find the mass of this, I put it on a scale. It's probably not going to say anything, it's going to say 0 grams. If I put on 100, it might tell me that they weigh 1 gram. And if I divide 1 gram by 100, I get 0.01 grams. And that would be how much one of the balls weigh.